The following video is the Zoom presentation of a MassDEP UMass Drinking Water Small Systems intern project on the value of water tools by Isak and Jalal, Akel. The MassDEP UMass Small Systems intern program is funded by a US EPA Safe Drinking Water Act grant to MassDEP in support of small drinking water systems throughout Massachusetts. This collaboration began when MassDEP's Yvette DePisa, Michael Maynard, and Art Screpitus saw opportunities for drinking water community involvement and operator training with students of UMass under the leadership of Professor David Reckhow, Professor John Tobiasen, and research engineer Patrick Whitbold. Previous intern projects have worked on lead in schools, small system assistance, operator certification, and other current drinking water topics such as PFAS. MassDEP would like to thank all of our partners on these projects, including the US EPA, Mass RWA, FERCOG, RCAP, and the UMass Group, especially Professor Reckhow, Patrick Whitbold, and the student interns. They've done hard work on this and all their other drinking water projects.
So, as Pat mentioned, my name's Amanda. That's Jalal.
I'm Jalal. Nice to meet you all.
Our project is value of water resources and tools. So for a little bit of background, why is water important and why should we care? So water is essential to life. Everything on earth requires water to survive and prosper. Water is used for growing crops and raising livestock, manufacturing countless goods that we use daily. It's used in households daily for things like cooking, cleaning, bathing, recreational purposes like in swimming pools or like gardening. According to the EPA, the average American family uses more than 300 gallons of water per day at home, with 70% of that water usage occurring indoors. So in the top left figure, you can kind of see a little pie chart of how like the percentage of water usage is broken down on average. And I just wanted to point out that, as you can see, leaks make up 12% of that water usage, which is actually, if you think about it, like a really big portion considering you use 300 gallons a day. And that can actually be avoided. So only 3% of the world's fresh water is deemed fit for human consumption. 1 billion people lack access to safe and clean water. Water scarcity includes pollution, overconsumption of water, transportation issues, drought, and governmental control. This scarcity causes many societal challenges such as hunger, disease, poor sanitation, lack of education, and poverty. So our objective for this project was to research and educate others on the importance of water tools. We're going to give a brief background of how water is currently treated and used, and we're going to follow that with existing water issues revolving around Massachusetts. Lastly, we're going to propose solutions on how to solve those issues. Specifically, we're going to cover the importance of community outreach and public awareness. So you can refer to the top right figure. So I'm just going to go really quickly through how drinking water is treated. So the general process involves about 5 basic steps. First is coagulation or flocculation, where chemicals containing a positive charge are added to the water to neutralize objects that have a negative charge, such as dirt. Those particles then bind together to form larger particles called floc. Next comes sedimentation, where the floc created settles to the bottom of the tank over time due to the weight and density as compared to that of water. The water on the top that does not contain floc is then collected and passed through a filter in order to remove particles of different sizes, starting from bigger particles. The next step in the process is disinfection. A disinfectant, such as chlorine, is added to the water to eliminate any remaining bacteria, viruses, or harmful particles. This process also helps so the water does not pick up any germs while passing through the pipes before reaching a household. And then the bottom figure, I'm just going to go quickly through how wastewater is treated. So generally, a wastewater treatment process involves about 6 steps. First, the wastewater that enters the plant from households, factories, businesses, and many other sources is screened, which means bigger objects such as rocks, wood, or other larger debris are removed so that they do not damage other equipment and materials in the plant.
Amanda, just for the sake of time, you can skip it because everyone here knows this.
Yeah.
Thank you, though. I'm not trying to be bossy. Just move to the next.
So this cycle of treating wastewater and drinking water is essential to life and is typically overlooked by many, allowing clean water to be taken for granted. It requires a great amount of energy, money, and manpower to keep this process running smoothly and allowing for potable water to come flowing out of a faucet, shower head, or hose. In addition, the successful execution of this process is crucial to reducing the impact humans have on the environment. Wastewater should be treated before it is allowed to enter a body of water in order to reduce pollution of the water and environment. Furthermore, drinking water must be treated before it is allowed to be sent out for human consumption in order to reduce illnesses and deaths caused by impure water.
Awesome. So the infrastructure problems, well, currently the water infrastructure is aging a lot in the US, and it's causing a lot of issues due to the lack of upkeep. So currently most pipes in the ground are between 10 and 100 years old, with some pipes in the Northeast dating back to over 200 years. You know, you can see a picture on the right of an aging rusty pipe that obviously needs to be changed, and that probably takes about 20 to 30 years for it to be like that. And Masters specifically, many water and wastewater investments were made in the 70s and 80s, so that means most of them now need to be repaired and replaced. And because of this aging infrastructure, there's an estimated 240,000 water main breaks per year in the United States, and that causes a loss of about $2.6 billion a year. If you can look at the figure on the right, you will see that the losses, there's two kinds of losses for water. There's the real losses and apparent losses of non-revenue water. And non-revenue water is basically clean, treated drinking water that's lost before it reaches the customer. So the real losses are the physical, actual losses of water from the distribution system. And the apparent losses are the non-physical losses due to measurements or inaccurate recordings. And so we lose about 7 billion gallons of water per day in the United States, and the amount of water lost in 1 year is enough to supply the 10 largest cities in the United States. Lost water accounts for billions of dollars in the lost revenue, and the amount of non-revenue water for utilities ranges up to about 30%. And most of these losses and the real losses are caused by leaks. 75% of drinking water investment needs repair and replacement because of leaky pipes. And there's like 700 main breaks per day in the United States. And as I mentioned before, 240,000 per year. And also tank overflows is a big loss. So we can fix that by slowing the flow. We can lower the operation maintenance costs, increase water availability, reduce the need for new sources and treatment plants, and diminish the impact from drought and climate change. And the apparent losses are usually from billing errors, theft, and reading inaccurate meter measurements.
Okay, so that poses the issue of where is the money going to come from to fix all of these issues. Many systems can't raise their water rates that their customers pay because of the effects that it could have on the community's low income. Currently, water rates do not accurately reflect the true cost of treating water, but they rely on state and federal funding to make up for that gap. Because of the Clean Water Act enacted in 1972, federal standards for water were increased. However, with these regulations, costs for treating water have also increased. In 1986, the SRF, or State Revolving Loan Fund, was created in order to provide states with loans to use towards water infrastructure and costs. Currently, all states in the U.S. have a prioritized list of systems that are to be granted SRF. However, that list is not very comprehensive and may not accurately reflect the need of the state systems. In addition, there are some restrictions associated with the loans that prevent some systems from being able to easily access the loans. Massachusetts is one of 4 states in the U.S. that does not have a primacy, meaning that they do not have responsibility for managing water pollution control over the federal government, which could prevent the state from being able to easily work more closely with the cities and towns to focus resources where they're needed most. In addition, as regulations become stricter, has been an increase in the need for energy, chemicals, and manpower, which has also increased the cost of water treatment. Many municipalities are now in debt in an attempt to keep up with this need. Also, as of 2019, 97% of American public water systems are considered small systems, meaning they serve less than 10,000 people. So it's crucial for these systems to be able to access funding in order to keep clean water running to their residents. And then another issue would be a need for operators. So as Christian and Emma previously mentioned, there's a need for operators. The drinking water and wastewater treatment process is very involved, and it requires a lot of manpower. So we need a lot of operators. Also, due to the increase in water regulations, specifically in Massachusetts, emphasis on nutrient control and stormwater mitigation. Training for operators has become kind of complex and therefore more expensive. So operators are highly sought after as an essential means of keeping clean water flowing to residents.
Cool. So for the solutions, we basically need to educate the public and the people in charge first about all these problems. And I think it's really important for municipalities first to learn about purple pipe systems, which are recycled water systems. That means it's filtered from certain solids and impurities, and that could be used for irrigating landscapes, cooling down industrial machinery, and perhaps to use for animals, to feed the animals. And they're colored in purple so that people can distinguish between what is safe to drink and what is not. So that basically it's good water. It's just we can't drink it. And instead of dumping it in the rivers and oceans and waterways, we can recycle it to use it for other things, which I think is great. And in Southern California in 1985, in the Irvine Ranch Water District is the first place to implement this system. Go on, Amanda. Yeah, so for community outreach and education, I think it's important to raise awareness about stormwater and what that can cause if it's not managed properly. So there's 3 things we can do with it: retention, infiltration, and detention. Retention is constructing wetlands and green storage of the groundwater. And then infiltration by doing bioswales and stormwater management of, sort of directing the water in certain places. And then detention, which is green roofs and rainwater harvesting. And these are flyers that I think could be sent to people in the mail or sent to municipalities or, just given to people at certain events. And so the second flyer here in the middle is about the sewer and water lines for people, for residential homes or municipalities. So it compares the sewer system and the water system and what it means for, the sewer to be not functioning well or the water not being good enough or something like that. And it compares what pipes is good to use, PVC, copper, steel, etc. And what happens if there's a break, what you can do, etc. And it's really important to mention to people and educate them about the value of tap water as opposed to bottled water. The flyer on the right has a very comprehensive graphic about what it takes to do bottled water. It causes 2.5 million tons of carbon dioxide in the atmosphere. It causes $1 billion of landfills of plastic, 17 billion barrels of oil in a year for production, 1 million gas cars for a year, transportation, etc. Yeah, so bottled water is really bad and people you need to know this. And lastly, we have a flyer or 2 for, obviously we mentioned before, somebody mentioned in the presentations that PFAS is a problem in wastewater. And so that comes from flushing stuff down the toilet. And so it's really important to let people know what to flush and what not to flush in the toilet. And this is a good flyer from Tata and Howard Company, engineering company. And on the right, this is a flyer about how to conserve water in the house and residences, especially in the summer. Check for leaks, how to wash the car, use a bucket instead of a hose, how to harvest rainwater, and there's a DIY procedure in the report from Tata and Howard as well. We can save 40 bathtubs of water a year by reducing our shower length time by 3 minutes only. We can use timely irrigation for the gardens. If we irrigate the gardens in the morning before sunset or at sunrise and before sunset, that means we can save a lot of water due to evaporation. Developing gray water systems so we can recycle the kitchen and shower wastewater to be used for irrigation and maybe feed the farm animals, etc. A lot of people use the hose to clean their porches and yards, so sweeping instead of using the hose saves a lot of water. We can develop a compost toilet system that is water-free and recycles nutrients to be fertilizer for the soil. And the autumn leaves that fall, you can use them as mulch and fertilizer or compost instead of blocking drainways and sewer systems. And yeah, so I think for these flyers we can, especially in kids at schools, a lot of schools don't teach children about the values of water. And I think if they have once or twice semester lectures or tours in wastewater treatment plants or just lectures or documentaries about the values of water, or maybe we can do monthly mailing flyers updates in the mail from municipalities to communities and stuff like that, and as well as operator training positions and opportunities.
Awesome.
Yeah.
Thank you, guys. I'm going to cut you off there just so we can get to the
so much.
last group.
We're
thank you
done,
for the
Pat.
presentation. And any questions for this group before we move to our last topic?
Hi, Patrick. This is Mike DeBarra from MassDEP.
Hi.
I was thinking a very simple campaign to sort of combine projects 4 and 5. For instance, the value of water for me as an operator, for you as a water customer, and for us, clean water to drink. Sort of trying to personalize this to tie in not only the need for water operators, but educating the public about what the true economic and environmental value is, and then on a larger picture. And you could have palm cards. So maybe this is an idea for a follow-up project, connecting those pieces. But I just wanted to say that as others have, everyone really did a terrific job. And there's a lot to think about here, and we're happy to follow up with you on some of these other ideas going forward.
Great, thank you. Yes, I couldn't agree with you more. Those two projects definitely intertwine immensely. And when we started the project, the goal was kind of maybe make some value of water tools or flyers, and then we learned quickly much of that is already out there. The Value of Water campaign has been out there for a while, and I think the big picture takeaway that we see from our end is just the need to get this information in front of young kids. And it doesn't necessarily mean making it part of the Common Core curriculum, but it definitely should be several times throughout the year, either 1-hour guest talks, field trips, and just education material provided by the state, ideally DEP, to schools and educators, to just to drive home into young children's minds that you need to protect your water, value your water, and then as they age through K through 12, just being, most people have never seen a water operator because it's on a remote part of town. They see a yellow truck drive by they think someone goes and checks fire hydrants all day, but in reality, it's much more than that. And there's, the idea of entering the field of water operations or anything to do with water, it just flies by, and so awareness needs to be the thing. And we had ideas, like even at parades and 4th of July celebrations, just giving thanks to water operators, wastewater operators, the same way you do police and fire and EMS. Those little things help get conversation going. But so I don't necessarily know exactly how to do all of that, but I think a future project from us or from others at the state would be trying to implement some of these things soon.
Sounds good. Thank you, Patrick, and great job.